In this lesson, we're going to be looking at average rates of change for rational functions. But before we can do that, we need to look at a topic called simplifying complex fractions. Now, when we deal with these average rates of change, we're going to end up with expressions that have fractions inside of fractions. And I'm going to look at an example here. 1 over x plus 1 over x plus 1 all over 1 over 3x. This is called a complex fraction. It is a fraction with fractions inside of it. And what we're going to do here is we're going to look at how to simplify this. What we want in the end is to not have any more fractions inside of the big fraction or the main fraction. Now there's a couple of different methods that we can use here, but for the ones that we're going to encounter with average rate of change, we're going to use the LCD method, which says the following. To simplify a complex fraction, multiply its numerator and denominator by the LCD of all of the smaller fractions inside the main one. So first we need to find the LCD of these fractions, and then we need to multiply the top and bottom by this LCD. To find the LCD of these fractions, we look at each of the denominators themselves. So we've got x, x plus 1, and 3x. And we factor each of them. Now, for the most part, these cannot be factored. X is just x. X plus 1 is just x plus 1. 3x is 3 times x. And then the LCD is going to be the product of all of the factors that appear in each of these denominators. So one factor that appears here is 3. So we need to include a 3 in our LCD. Another factor that appears is x. In fact, this appears in multiple denominators. So our LCD also has to contain a factor of x. And then lastly, we've got a factor of x plus 1. So our LCD has to contain the factor x plus 1 as well. So our LCD is going to end up being 3x times x plus 1. So what we're going to do here is we're going to multiply the top and bottom by 3x times x plus 1. The reason we're allowed to do this is because we are effectively multiplying by the fraction 3x times x plus 1 over 3x times x plus 1, and any fraction where the numerator and denominator are equal is equal to 1. Anything divided by itself is 1. So we are multiplying the original expression by 1, which doesn't end up changing its value. Now, we have to take 3x times x plus 1 and distribute it to each of the fractions on the inside. Let's take a look at this first fraction. Here we have one thing that's going to cancel, specifically x, because we've got an x in the denominator and an x on the outside. So those x's are going to cancel, and we're going to be left with 1 times 3 times x plus 1, and 1 times 3 is 3, so that's going to be 3 times x plus 1. I'm not actually going to cross out the x's, because while this x cancels with this x, when we distribute to the other term, we have the x plus 1's that cancel. So we don't want to actually cross something out, or we might accidentally think that it cancels in more than one term. Now, let's look at what happens when we multiply all of this times the second fraction. The factor that cancels here is x plus 1, because we've got 1 in the denominator and 1 out front. And so we have 1 times 3x, which is just 3x. Now in the denominator, we have to multiply 3x times x plus 1 into this fraction. And the thing that factors is the 3x, so we end up with 1 times x plus 1, which is just x plus 1. Notice that by multiplying the top and bottom by the LCD, we've gotten rid of all of the fractions in the numerator and denominator, which is what we wanted. The last thing we need to do here is get rid of the parentheses by distributing and combine like terms and see if anything else can be simplified. So let's distribute this 3. That gives us 3x plus 3, and then plus the other 3x over x plus 1. When we combine like terms, 3x plus 3x gives us 6x. So we've got 6x plus 3 over x plus 1. And there's one last thing we want to do. We want to factor the top to make sure there aren't any factors that can cancel between the top and the bottom. So in the numerator, there's a GCF of 3 that we can pull out. When we do that, that leaves us with 2x plus 1 as leftovers. And we've got x plus 1 in the denominator. We notice that there aren't any factors that can cancel between the top and the bottom. And so this is our final answer. In fact, this would also work as a final answer. Both of these are equivalent. Both of these are nice. One of them is factored, whereas one of them has all the terms multiplied out. Either one of these is acceptable as a final answer. Please get a little bit of practice working on the linked example problems so that you're prepared for the next part of the lesson where we look at average rate of change of rational functions.